Hi everyone, this time I would like to create a video series about the deep learning research on point cloud data. I'm a PhD student from Vision and Learning Lab at National Chiao Tung University in Taiwan. You can call me RDN. I hope that with this video series, it can provide us a basic understanding, building block understanding of the deep learning research on the point cloud data. Here I select the 6 most representative paper, in my opinion, that can help us again to understand the deep learning research on this point cloud data. The first two paper research here is the pioneer of the 3D backbone. We have PointNet here, and the next is PointNet++, is just basically the further development of this PointNet. And then in the third paper here, we will learn about the very important property, which is the rotation invariant or pose invariant. So no matter the rotations or pose we accept in the input point cloud here, the output performance of the network should be the same. If we rotate in any degree, the output performance should be as good as if we do not rotate. So this is what we expect from this property. And then in the fourth paper here, we will talk about the simplifications of the point cloud representations, which we call this super point. So let's say if we have like 1 million point cloud, we will make this point cloud into cluster. The number of cluster will be much lesser than the 1 million, and it will simplify the task. For example, later we can use for segmentations or for detections and so on. Okay, and then in the last two paper here, this is the more further development of the point cloud research. In this number 5 here, we will start to consider multiple modality. So for example, we will consider image and also text or language to help to understand the 3D point cloud here. Later, we will see VLM, Vision Language Model, that can help us to understand the point cloud here. And then the last paper here, this is the very popular downstream task application, which is point cloud generative model. And in particular, I select this paper, de facto, from ICCV 2023 because this is, I think this is special because this paper can provide ability to control the generated shape. For example, if we have chair A here, and we have another chair B, and then if we want to like generate a new chair C, we can like control that, oh, the leg of the C will be from this style of the chair B, and then the back of the chair from C will be the style from the chair A here. So we can have this kind of controllability. So I think that will be interesting to discuss. Yeah, so that's it for the 6 important work that I believe hopefully it can help us to give a basic building block understanding if we jump into the deep learning research on point cloud, or for those people that just want to do engineering thing, working with the state of the art. I hope that from this video series can also give a stronger understanding how everything works behind the scene. Okay, so let's go first in this introduction section. In these sections, I will discuss about the most common 3D representations. So in this video series, we will use this point cloud, but I will just give the overview, like we have other data representations of the 3D model. The first representation is the mesh model. We have these visualizations. This is the rapid 3D model. This is the mesh representation. This is the point cloud, and this is the voxel representation. So the mesh representation is basically just, it consists of triangle faces. Like here we have the triangle. For example, like this, I draw larger here. And this triangle faces is just basically consists of vertex. For example, this one is, we have 3 vertices here. And these faces are connected by these edges here. this edge, and this another edge here, we have the triangle face. And we have a lot of triangle face that construct this object of rabbit here. And then we can see that if we have a more detailed shape in this particular region here, we will need more faces, right? So probably to represent this single object, it can be like, this is just for example, like 100,000 faces. So if we use this for recognitions, it can be computationally expensive. So that's why we have another data representations that are cheaper, computationally cheaper. And the use case of this mesh representation is usually for those applications that need a detailed quality, the high quality of the image, of the visualizations. For example, if those people that use this model for animations or for very detailed 3D assets, they can use this mesh representation. And then the next representation is point cloud that we will again discuss in this video series. Basically, it's just the sparse representations of this compact representation mesh here. For example, we have this face, right? We can just sample for every face here. We sample several points, sample several dots. For example, we can uniformly sample based on the area of this face. If the face are large, we can sample more. In the face are more narrow, so probably we can just sample a less point here. So this is sparse. For example, if we have 100k face here, we can just sample into much lesser. It can be like 1,000, 2,000, or even much lesser than that. It just depends the applications. And then the use case is usually we will use for recognition. For example, we have the sensor like LiDAR. LiDAR will just we have the light, and the light will hit the surrounding environment. For example, if we have the self-driving car, we have this LiDAR sensor. This sensor will hit the surrounding environment, and the data is stored as the collection of point, or this point cloud. And later we use this data point cloud for understanding the surrounding of this self-driving car. Yeah, so usually we use this point cloud for the recognition, because again, this is sparse, so that this is computationally cheaper. And then another data representation is a voxel. Voxel is basically just 3D grid volumetric. So if we have this mesh, we just make this in the discrete volume. If we have the smaller cubic, smaller volume, we have the more detailed representation, right? So if we have the more higher size of the volume, we have the less detail. And this voxel is also some of the work on the recognitions. I also see that some of them use the voxel representation, especially in the early development of this 3D understanding, because voxel are regular, right? Regular. And we have the 2D backbone, like the CNN, convolutional neural network. Image is also regular. So people in the early states, they just adopt the 2D CNN into 3D CNN and apply to this voxel data, and that's it. We can also do the recognitions. But again, this is relatively expensive, computationally expensive, if we compare with this point cloud. And then another use case, we also can use 3D assets for less detailed. For example, if we want to represent a wall or the shape that can be represented by this voxel-like shape. Okay, so yeah, that's it for these introductions. Before we end the sections, I have some disclaimer. So during this video series, I will try to give some details until we can understand how this method works in details. However, there are some possibilities that the implementation details, for example, like the embedding size, tensor shape, may be different to the paper. Yeah, this is very, I believe this is quite minor. So this do not really impact our understanding about how the method works. So if you want to like really follow the exact details, you can just cross-check in the corresponding papers. Yeah, so this is the first disclaimer. And then the second disclaimer is I made this video series in the early 2025. So probably if you watch this video few years later, probably you think that, oh, the paper is too old. But I believe some of the some of the basic building block here, I believe that even like 5 years later or 10 years later, this basic building block are still important, because this is the pioneer in the 3D understanding. So the idea is very basic. So I believe that in the new paper, usually they just build on top of the previous idea, and this is just the basic idea of the 3D understanding. So I hope that even though 5 years later, 10 years later, some of them are still relevant, that give us the understanding to this 3D point cloud understanding, especially those that use a deep learning method. I think that's it for this video sections, and see you later in the next video. We will discuss the paper one by one.